On the coastal plains of South Texas, where the land meets the vast expanse of the ocean, a new era is taking shape. Here, history is being forged in fire and ambition, as SpaceX pushes the boundaries of what's possible. The upcoming launch of SpaceX's Starship Flight 11 is more than a test flight. It's the grand finale for the second version of Starship, a design that's shaped the future of rocketry. This launch represents years of innovation, countless hours of engineering, and the relentless pursuit of excellence. This mission is a final, glorious data-gathering exercise, paving the way for an even more capable, reusable future. Engineers and scientists are meticulously monitoring every detail, ensuring that each piece of data collected will contribute to the next leap forward. The timing is poetic. Exactly 1 year after Starship Flight 5 proved the upper stage could perform its critical engine burn in space. This anniversary marks a significant milestone in the journey towards making space travel more routine and reliable. Now, Flight 11 stands as a bookend to an entire phase of development, a celebration of learning from both success and failure. Each launch, each test, has brought invaluable lessons that have been meticulously analyzed and applied. The goal is no longer just to reach orbit, but to master reusability and turn science fiction into routine engineering. This mission is a testament to that vision, aiming to make space travel as common as air travel. The vehicle, a 121-meter stack of stainless steel, is the most powerful rocket ever built, designed to make space accessible. Its sheer size and power are a marvel of modern engineering, standing as a beacon of human ingenuity. Data from this flight will lay the foundation for the next generation, the larger, more advanced version 3 Starship. This new iteration promises to push the boundaries even further, with enhanced capabilities and greater efficiency. Starship is NASA's choice for the Artemis moon landings and the cornerstone of Elon Musk's vision for Mars. It represents a critical component in humanity's quest to explore and inhabit other worlds. Flight 11 is a critical stepping stone, bringing the dream of a multi-planetary species closer to reality. Each launch brings us one step nearer to the stars, turning what was once a distant dream into an achievable goal. In the hours before liftoff, anticipation hangs thick in the air. The world seems to hold its breath as the first rays of sunlight illuminate the towering rocket, casting long shadows across the launch pad. Starbase becomes a hive of high-stakes activity, with teams moving purposefully across the sprawling complex, each person playing a vital role in the unfolding drama. The pre-launch sequence is a symphony of procedures, loading super-chilled liquid oxygen and methane, each step choreographed with precision and care. The rocket begins to vent white vapor, a visible sign that it's coming alive, as the cryogenic propellants interact with the morning air. Timing is everything. Cryogenic propellants must be loaded precisely, down to the second, to ensure optimal performance at launch. Meanwhile, engineers monitor thousands of data channels, eyes fixed on screens, ready to respond to any anomaly. Engine chill-down begins, prepping the 33 Raptor engines for ignition. Super-cold propellants flow through the engines, conditioning them for the inferno to come. As the countdown nears zero, excitement builds not just among the teams, but also among the crowds gathered nearby, their eyes fixed on the rocket. A live webcast brings millions together for this shared moment. Final automated checks cascade through the system, each one a green light toward history. The flight termination system is armed, a critical safety measure, as the final seconds tick away. The water deluge system is primed, ready to protect the pad from the fury of ignition. The last go-no-go poll is conducted. Years of work, dreams and sleepless nights hang in the balance as the team gives their final affirmations. The rocket takes control of the countdown, its onboard computers now orchestrating the final moments before flight. Hold-down clamps prepare to release, gripping the rocket with immense force as the engines roar to life. The engine ignition sequence begins, building to an earth-shattering crescendo of fire and thunder. For a few heart-stopping seconds, all engines fire at full thrust, while the rocket remains anchored, the ground trembling beneath the power. If all is well, the clamps release, unleashing the rocket's full might, and Starship climbs toward the heavens, a testament to human ingenuity and the relentless pursuit of the stars. Liftoff is a raw display of power, shaking the ground for miles. The Super Heavy booster's engines ignite, lifting the rocket majestically from the pad. A torrent of flame and vapor engulfs the tower, a breathtaking spectacle. The ascent is a balance of force and control, with engines gimbaling to steer the rocket. Starship soon faces Max Q, the point of maximum aerodynamic pressure, a true test of its structure. Passing Max Q is a milestone. Relief sweeps mission control. The booster's engines burn for about 2.5 minutes, pushing the upper stage toward space. As propellant runs low, the rocket prepares for stage separation, the booster's job nearly done. 2.5 minutes in, high above the Gulf, the mission enters hot staging. The upper stage's engines ignite before the booster shuts down, blasting fire and plasma to push the stages apart. Ship 37 continues its ascent, aiming for orbital velocity, over 27,000 km/h. The goal: a trans-atmospheric orbit, setting up crucial tests before deorbit. Meanwhile, Booster 15 flips for its boost-back burn, testing maneuvers for future recoveries. It falls back through the atmosphere using grid fins to steer. The final step, a new 5-engine landing burn, aiming for a controlled splashdown. Though not recovered, the data will perfect future booster catches. Every second of descent is a masterclass in controlled chaos. With the booster on its way down, Ship 37 tackles ambitious objectives. First, deploying 8 simulated Starlink satellites testing the payload bay's mechanism. Next, an in-space engine reignition test, crucial for interplanetary travel and safe returns. A successful reignition proves Starship is a true maneuverable spacecraft, the most dramatic test re-entry. Ship 37 will plunge belly first, its heat shield facing temperatures over 1,500 degrees Celsius. Some tiles are intentionally missing, pushing the shield to its limits and gathering vital data. This is SpaceX's philosophy test: break, learn, improve. The mission ends with a controlled splashdown off Australia, a triumphant finale. Starship Flight 11 marks a poignant milestone, the final chapter for version 2 hardware. It's a moment of reflection and celebration, as we say goodbye to a generation that has defined SpaceX's rapid progress in reusable rocketry. Both Ship 37 and Booster 15 stand as the last representatives of their line, destined to be sacrificed in the name of science and the relentless pursuit of data. Their flights have pushed boundaries and set new benchmarks for what's possible. This generation of Starship hardware took the leap from early suborbital hops to ambitious full-stack orbital flights, enduring setbacks, learning from failures, and ultimately achieving remarkable successes that have inspired engineers and space enthusiasts worldwide. The decision to retire version 2 is a testament to SpaceX's relentless drive for improvement. Even as these vehicles fly, version 3 is already under construction, promising to build on every lesson learned to mission sewer. The upcoming stack will be taller, stronger, and engineered for even faster turnaround between flights. Every upgrade is informed by the data and experience gained from missions like Flight 11, ensuring each new version is a leap forward. Booster 15's journey is a perfect example of SpaceX's commitment to reusability. This is its second flight, and most of its engines have already proven themselves in previous missions, showcasing the durability and reliability of the design. Flying it again, even in an expendable role, provides engineers with invaluable data on how components age and perform under stress, helping to refine future designs for even greater longevity. With version 2 stepping aside, the path is now clear for version 3 to make its debut on Flight 12, ushering in a new era of innovation and capability for the Starship program. And SpaceX isn't stopping there. Version 4 is already being conceptualized, promising to be even taller, more advanced, and more efficient, as the company continues to push the boundaries of spaceflight. Flight 11 is more than just a launch. It's a celebration of progress, a tribute to the hardware that brought us here, and a clear signal that the pace of innovation is only accelerating as we look to the future. Every Starship flight is a step toward humanity's dream of living among the stars. Starship's core principle is full, rapid reusability, lowering the cost of space access and making Moon and Mars missions practical. NASA's Artemis astronauts will descend to the lunar surface in a Starship, and every test brings that future closer. Beyond the Moon, Starship was designed for Mars. Elon Musk's vision is a self-sustaining city on the red planet. The vehicle's capacity and refueling abilities are key to this audacious goal. The first crewed Mars flights, once science fiction, are now targeted for as early as 2029. Each mission builds confidence, inspires new generations, and brings space within reach. Starship Flight 11 is more than technology. It's a symbol of human curiosity and ingenuity. With every launch, we test the limits of possibility and write the next chapter of our story. The stars are calling, and with Starship, we are building our answer.